Hello viewers, welcome to my channel. I am Hasham Ali Khan. So far 8 problems I have completed on sequencing. In this video, 9th problem I am going to explain you. This problem is entirely different from the previous problems. Don't think that all the problems are same. Every problem, 1 or 2 new points we will come across. In this problem, the conditions will not be satisfied. Previous 2 problems I have explained you, the 2 conditions are there. If any one of the condition is satisfied, we can convert the 3 machine problem into 2 machine problem and can find out the optimum sequence. But what will happen if both the conditions are not satisfied? In that case, what is the remedy? So here in this problem, I am going to explain you that situation where both the conditions are not satisfied. Then we have to apply a new technique. That technique is called CDS technique. C stands for Campbell, D stands for Dudek, and S stands for Smith. So these persons have given a technique in order to solve the situation where the conditions are not satisfied. So before starting problem number 9, I expect my viewers to have a printout of the problems which I have given in the link under my description. Take the screenshot of the points, then I'll explain all the points. Come on, see the 9th problem. It takes 3 processes P, Q and R and 4 jobs to complete work. So here 4 jobs are there and 3 processes. Processes are just like machines. Sequence them to get minimum time in minutes. So all the processing times are given in minutes. The process centers, that is just like machines, P, Q, R, and the jobs are 1, 2, 3, 4. So 3 machines and 4 jobs. So first of all, we'll put the data, whatever is given, jobs 1, 2, 3, 4, machines P, Q, R, and these are the processing time in minutes given. Now, before applying the technique, we have to check the conditions. The condition is the smallest of first machine, largest of second machine, and smallest the third machine. The smallest of machine P, 14, 20, 8, 18. So 8 is minimum. And the largest time of Q machine, second machine, 20, 15, 16, 10. So 20 is the highest. And the smallest of the last R machine, 25, 17, 4, 12. So 4 is the small. The smallest of P, 8, largest of Q, 20, and smallest of R, 4. What is the first condition? The smallest of the first machine should be greater than or equal to the largest of the second machine. So smallest of P should be greater than or equal to the largest of Q. Is the smallest P greater? No. 8 is less than 20. That means first condition not satisfied. Second condition, smallest of R should be greater than equal to largest of Q. We are comparing R with Q. Smallest of R is 4. It should be greater than the largest of Q. Largest of Q is 24. Is 4 greater than 20? No, 4 is less than 20. That means both the conditions are not satisfied. In that case, we cannot go to the previous technique of making 2 fictitious machines, what we have done in the previous problems. Here the new technique to be applied is called CDS technique. And already in the theory video, I have explained you about this CDS technique. Briefly, I'll explain. Suppose if there are 3 machines, the number of stages required are M minus 3. M stands for number of stages. Number of machines, sorry. M stands for number of machines. So if 3 machines are there, so M minus 1, 3 minus 1, 2. In 2 stages, we get the answer. If there are only 3 machines. If there are 4 machines, then M minus 4, 4 minus 1, that is 3 stages. Like that, number of stages required depends on M minus 1. M stands for number of machines. So what is the first stage? In the first stage, take the first machine and the last machine and ignore in between all the machines. You just ignore. Take the first and the last. find out the optimum sequence and the total elapsed time. First stage over. Now come to second stage. In the second stage, join the first two and make it one machine, and join the last two and make it one machine. So we are converting three machines into two machines. First two we have joined and the last two we have joined. Again we calculate optimum sequence and then total elapsed time. So first stage we have ascertained the total elapsed time and optimum sequence. In second stage also again we have to find out the optimum sequence and the total elapsed time. If there are only three machines, we require only two stages. Stage 1, take the first machine and the last machine. Ignore the middle machines. Second stage, combine the first two and make it one machine. And the second, combine the last two and make it one machine. So convert into two machines. Again find out the optimum sequence and find out the total elapsed time. Compare these two stages total elapsed time. Whichever stage has lower total elapsed time, that stage is the optimum sequence. Right? Suppose if there are four machines, the number of stages 4 minus 1, 3 stages. So what we are going to do in 3 stages, first stage, take the first machine and the last machine. Ignore the middle two machines. Find out the optimum sequence. Find out the total elapsed time. First stage over. Second stage, combine the first two and make it one machine. Combine the last two and make it one machine. Again find out the optimum sequence. Find out the total elapsed time. Third stage, combine the first three machines and make it one machine. Combine the last three machines and make it one machine. Find out the optimum sequence. Find out the total elapsed time. 3 stages over. Now compare what is the total elapsed time of first stage, second stage, third stage. Whichever stage has lower total elapsed time, that stage sequence is the optimum sequence. Like that we can extend to 5 machines or 6 machines, any number of machines. This is according to CDS method. Now coming to our problem. In our problem, how many machines do we have? 3 machines. The number of stages required 3 minus 1, 2 stages, right? Stage 1, consider the first machine and the last machine, P and R. Ignore this Q. So P and R, the values are 14, 28, 18, 25, 17, 4, 12. These 2 machines. Applying the Johnson's rule, make the optimum assignment. I'm not going by step. Here, what is the minimum time? Minimum time is 4, right? So on which machine and which job? It is on R machine, second machine. So we have to assign from right. So this third job, I am assigning to the right. So third job over. Now remaining 3 jobs, what is the minimum time here? 14, 20, 25, 17, 18, 12. 12 is the minimum. For job number 4 on second machine. Second machine means again from right side. So before 3, I have taken 4. 3 and 4. First I have taken 3, then I have taken 4. Now 2 more jobs are left. 14, 20, 25, 17. Minimum is 14. For job number 1 on P machine, first machine. So left side first, this one over. Now only one job is there and one cell is there. This second job I have put here. The optimum sequence 1, 2, 4, 3. This is according to Johnson's rule. Now we calculate what is the total elapsed time for this optimum sequence. So here job number 1, 2, 4, 3. This is the optimum sequence. Now machine P. So applying the Johnson's rule, we can get the optimum sequence as 1, 2, 4, 3. This is a sequence given by the first stage. We have to find out what is the total elapsed time for this sequence. Then we have to go for the second stage. Again, we have to find out the optimum sequence and the total elapsed time. Then we have to compare both the total elapsed time. Whichever sequence has lower total elapsed time, that sequence will be considered as the optimum. So here we are calculating the total elapsed time for first stage, stage 1. So 1, 2, 4, 3, starting time 0. The P machine first job, check. What is the P machine first job? 14 minutes. So 0 to 14. Immediately we'll start the next job, second, from 14. Second job, P machine, 20. So 14 plus 20, 34. 34 will start fourth job, machine P. Fourth job, machine P, 18. So 34 plus 18, 52. From 52 will start third job, P machine, 8. 52 plus 8, 60. This is for machine P, starting at 0 time and ending at 60 minutes. This is the complete processing time for machine P. No break in between. Now, the machine Q will start when the work of machine P is over. So, machine P completes at 14 minutes. So, immediately at 14 minutes will start machine Q. So, first 14 minutes, machine Q was idle. Idle time 14. Right? Now, first job Q machine. First job Q machine, 20. So, 14 plus 20, 34. Now, compare 34 and 34. Both are same. That means simultaneously the work is completed on first job. Here work is completed for second job. So at 34 it will start. No idle time. So second job Q machine. Second job Q machine is 15. So add up 34 plus 15. 49. Now 49 or 52. Whichever is higher. 52 is higher. That means here the machine remains idle for some time. 52 minus 49 is 3. 3 minutes idle, right? So fourth job Q machine. Fourth job Q machine, 10. So 52 plus 10, 62, right? Now 62 is the out time, finishing time. Whereas 60 is the out time for P machine. Whichever is higher, 62 is higher. So there is no idle time. Third Q is 16. So 62 plus 16, 78, right? The total idle time is 17 minutes. Machine Q over, last machine R. Machine R will start only after the work is done by machine Q. So machine Q completed at 34 minutes. So at 34th minute, R will start. So first 34 minutes, R was idle. Now, first job R machine. First job R machine, 25. So 34 plus 25, 59. First 34 minutes is the idle time. Now 59 or 49, whichever is higher. 59 is higher. There is no idle time. 59, no idle time. So second job R machine. Second job R machine, 17. So 59 plus 17, 76. Now 76 or 62, whichever is higher. 76 is higher. No idle time. So fourth job R machine. Fourth job R machine is 12. Now add up 76 plus 12, 88. 88 or 78, whichever is higher. 88 is higher. No idle time. Then third job R machine, 4. So 88 plus 4, 92. The total idle time is 34. Total elapsed time is 92 minutes. So in the first stage, we have considered the first machine and the last machine, ignored the middle machine. And we have found out the optimum sequence, and also we have calculated the total elapsed time. Now we are coming to the second stage. What will happen in stage 2? Consider the machine G and H. Two imaginary machines we are making, G and H. G is nothing but P plus Q. First two machines we add up and make it G. And H, add up the last two machines, Q and R. Right? In this way, we are converting the 3 machine into 2 machine problem. So first G machine, P and Q. 14 plus 20, 34. 20 plus 15, 35. 8 plus 16, 24. 18 plus 10, 28. Last two machines. 20 plus 25, 45. 15 plus 17, 32. 16 plus 4, 20. 10 plus 12, 22. That's all. Now, applying the Johnson's rule, again we find out what is the optimum sequence. What is the minimum time among all these values? 20 is the minimum. For which job? Third job. On which machine? H machine. Second machine. To right side. So this third job we will assign here. Last cell. So one job is over. Now remaining jobs. What is the minimum? 22 is the minimum. 22 is for fourth job on machine H. Again from the right side. So before 3 I am taking 4. Fourth job also over. अब remaining two jobs are left, 1 and 2. What is the minimum here? 32. 32 is the minimum. So 32 is the minimum means now remaining two jobs, 1 and 2. The minimum is 32. 32 is on which job, which machine? Second machine. So again from right side. So here I have assigned 2. So this job. Lastly, one job is left and one cell is left. That is first one. So again we got 1, 2, 4, 3. Here also we got 1, 2, 4, 3. That means the sequence has not changed in stage 1 and stage 2. That means the total elapsed time will also be same. When sequence is same, the total elapsed time will also be same. The total elapsed time is 92 minutes for both the stages. But it will not happen every time. Only for this situation, we are getting, fortunately, both are same. Both sequences are same. In the coming problems, you will get different. Here you are getting 92 minutes. Suppose in the second stage you may get 90 minutes. Total elapsed time 90 minutes. So whichever lower elapsed time, that sequence we select as optimum. Right? Here fortunately we are having same optimum sequence and the same total elapsed time. So the total elapsed time, the optimum sequence is 1, 2, 4, 3. 1, 2, 4, 3. 1, 2, 4, 3. And the total elapsed time is 92 minutes. And the idle time for machine P, the complete work was done in 60 minutes, whereas the total elapsed time is 92. So 92 minus 60 is 32 minutes. This is the idle time for machine P. Now machine Q, the machine Q idle time is 17 minutes plus. When the work is finished here, 78. What is the total elapsed time? 92. So 92 minus 78, you will get 14. So 17 plus 14, 31 minutes is the idle time for machine Q. Last machine R. Machine R total idle time, here only we got 34 minutes. That's it. So this problem is entirely different problem where we are having 3 machines and 4 jobs, but the conditions are not satisfied. If the conditions are not satisfied, then we have to apply CDS method. Under CDS method, we have to find out in stages. First stage, second stage, third stage, fourth stage. Number of stages depends on number of machines. That's why number of stages required is m minus 1. Suppose 3 machines are there, 3 minus 1. In 2 stages, we get the answer. If 4 machines are there, 4 minus 1, 3 stages we require. If 5 machines are there, 5 minus 1, 4 stages we require. So what will happen in each stage? First stage, consider the first machine and the last machine, ignore all the machines in between. Find out the optimum sequence, find out the total elapsed time, over. First stage completed. Second stage, combine the first 2 machines and the last 2 machines and make it one machine. First 2 as G machine and last 2 as H machine. Again find out the optimum sequence, again find out the total elapsed time. Keep it separate. Now stage number 3. Combine the first 3 machines as one machine and combine last 3 machines as one machine. Again 2 machines are there. Find out the optimum sequence, find out the total elapsed time. How many stages completed? 3 stages. If 4 stages are, 4th stage is also there. combine the first 4 and the last 4, like that. After calculating this, compare all the total elapsed time. Whichever stage has a lower total elapsed time, that sequence will be called optimum sequence. That's it. So this is the first problem in which we have applied the CDS method. Inshallah, we'll continue the next problem in the next video.